All right, let's pull back the curtain on something we all do, probably dozens of times a day, without even thinking about it, searching the web. We're going to break down the absolute magic that happens behind that simple little search box. I mean, really stop and think about it for a second. You type in a few words, hit enter, and blink. In less than a second, you get a sorted list of the most relevant things from billions of possibilities. How in the world is that even possible? Well, that's exactly what we're here to figure out. So, to really appreciate the solution, you have to get your head around the sheer scale of the problem. The best way to think about the World Wide Web is to imagine a library, but, not just any library. This one has no walls, no central card catalog, and new books are being written and added every single second. To start, just picture our library having over 285 million separate buildings. That's roughly how many web servers are online. Each one is a potential source of information just scattered all across the planet. And then inside those buildings, you have the pages themselves. Now, the last solid count was over 20 billion, and that was a while ago. Today, that number is just, well, it's astronomically bigger. The scale is almost impossible to comprehend. And here's the real kicker, the part that breaks your brain a little. Because of things that are generated on the fly, like think about an online calendar that can create a unique web page for any day, past or future. The web doesn't really have a size limit. It can just create new pages whenever it needs to. So for a search engine, the library it's trying to catalog is, for all practical purposes, infinite. So how do you even begin to map something that's infinite and chaotic? Well, computer scientists came up with this really elegant solution. They stopped seeing the web as a messy jumble of pages and started seeing it as a graph. It's simple, really. Every page is a point, or a node, and every single hyperlink is a connection, an edge that leads from one node to another. Suddenly, there's a mathematical structure to all that chaos. And what's wild is that when researchers mapped this graph, they discovered it has this fascinating bow tie shape. Right in the middle, you have the core, a bunch of pages that are all really tightly linked to each other. Then you got the in group. Think of like a brand new website that links out to major news sites in the core, but nobody in the core knows about it yet to link back. The out group is the opposite, maybe old, unmaintained pages that the core links to, but they don't link back. And then you've got these countless little islands, pages with no links going in or out at all. They're just floating out there. Okay, so we've got a map of our infinite library. The next logical step, right? We have to actually go read all the books and create a master index, a giant card catalog that tells us what's inside every single page. And this is done with something called the crawler indexer architecture. First, you have these little automated programs, sometimes called crawlers or spiders, that just tirelessly travel across that web graph we talked about. They follow the links from page to page, making a copy of everything they find. Second, all those copies get saved in a gigantic database. And finally, an indexer program churns through that whole repository and builds the actual searchable index, basically making a note of every word and which page it appeared on. Of course, as the web just exploded in size, the way they did this had to change big time. Early search engines tried to do everything on one giant, centralized supercomputer, but it just couldn't keep up. Today's search engines use what's called a massively parallel system. They spread the work of crawling, storing, and indexing across thousands upon thousands of machines in data centers all over the world. It's the only way. So we found billions of pages that have your search words on them. Great. But which one should be number one? Which one should be number two? This is, without a doubt, the hardest and most important part of search. This is the art of ranking. The real revolution in search, the thing that changed the game, came from this one very simple, very powerful idea. See, before this, search engines mostly just counted how many times your search term showed up on a page. But what if you looked at the links pointing to a page? A link is basically a recommendation, a vote. And that led to the big insight. Good pages tend to get votes from other good pages. It was a massive shift from ranking what a page says about itself to ranking what the entire web thinks about that page. This idea was baked into an algorithm called PageRank. It basically calculates a general authority score for every single page on the web, just based on that link structure. The important thing here is that it's query independent. That score is calculated way ahead of time, not when you're searching. And here's the key. Not all votes are equal. A link or a vote from a super important page like Wikipedia is worth way, way more than a link from some random personal blog. Now, there's another key algorithm called hits, and it takes a totally different tack. Unlike PageRank, Hits is query dependent. It only runs after you hit search. For your specific search, it tries to find two kinds of special pages. First, there are authorities. These are the pages that seem to have the best info on your topic. And then there are hubs. Hubs don't have the answer themselves, but they're really good at linking to the best authorities. You see the relationship? A good hub points to good authorities, and a good authority gets pointed to by good hubs. So let's just nail this down because it's the critical difference. PageRank gives every page on the web a static, general importance score. Think of it like its overall reputation. Hits, on the other hand, dynamically finds the topic experts and the best lists of those experts just for the specific thing you're searching for right now. Modern search engines, of course, use a crazy complex mix of these ideas, plus hundreds of other signals. Now, you know how it goes. Whenever you create a system that ranks things based on a set of rules, you can bet someone is going to try and game that system. In the world of search, this is called web spam, or spamdexing, and it is a constant, high-stakes cat-and-mouse game. And spammers have gotten pretty creative with their deceptive techniques. They build these things called link farms, entire networks of websites that exist for no other reason than to link to each other to make them all seem more important. They use cloaking, where they show a perfectly normal-looking page to the search engine's crawler, but show a completely different, spammy page to you, the human user. They'll stuff pages with invisible keywords, or even use bots to automatically click on their own links to make them seem popular. It's a constant battle. And it is really, really important here to draw a clear line between this malicious spam and legitimate search engine optimization, or SEO. Good SEO is just the practice of making your website's content and structure clear so that search engines can actually understand what it's about and rank it correctly. Web spam is all about deception. Good SEO is all about clarity. Big difference. So after all of that, after crawling an infinite library, building a gigantic index, running unbelievably complex ranking algorithms, and fighting off an army of spammers, we finally arrive at the page you see every single day, the search engine results page. And this page, the SERP, is a highly engineered piece of digital real estate. In the main area, you have your organic results. Those are the product of all those ranking algorithms we just talked about. Then you usually have sponsored results, the ads, at the top or on the side. And you have all these other little helpful things, like related searches, designed to help you out if you didn't quite find what you were looking for on the first try. You know, one of the biggest changes in search over the years has been this move away from just being a list of 10 blue links. For searches that seem to have a single factual answer, engines now use what are called one-box results. The whole goal is to give you the answer right there on the page, so you don't even have to click on anything. Here's a perfect example. You search for weather Haifa, and you don't just get a link to a weather website. You get the weather. Boom. The temperature, the conditions, the forecast, it's all right there. This is search evolving from being a directory of information into a direct answer engine. So, from an infinite, chaotic library to a direct answer on your screen in milliseconds. The journey of a single search query is honestly one of the great engineering marvels of our time. And it kind of leaves us with this final thought to chew on. As these systems get even smarter, even better at predicting what we want and just giving us the answer, how is that going to change the fundamental way we look for information, the way we think, and maybe even the way we learn? Something to think about. Thanks for watching.